Hello and welcome to today's video. Today's video is for Advanced Geometry Chapter 11, Section 4, Volumes of Prisms and Cylinders. I think the volume sections are easier than the surface area, so we will do sections 11.4 and 11.5 together, and they are very much related. The first thing we start out with is volume is the space that a figure occupies. And we're going to use this Cavalieri's principle. It says if two space figures have the same height and the same cross-sectional area at every level, then they have to have the same volume. And it's really nice. I like this little sticky note drawing that is in your packet. So what they're saying, we could think of the volume as being, the surface area of the sticky notes. And we take all the sticky notes, put them together, and that becomes our volume. Well, if we take a stack of sticky notes or pieces of paper and we just push them off to the side a little bit, we don't change the volume. We will change the surface area, but the volume is going to stay the same. So which is going to make doing volume of oblique figures a whole lot easier than doing surface area. Okay, so that's Cavalieri's principle. So the volume of a prism is, what you do is you take the cross-sectional area. Now the prism is, we'll turn it so the bases are in such a way that the cross-sectional area is going to be the same the whole way up. And if we do that, as long as the cross-sectional area is the same way all the way up, then the volume is just the area of the base times how high it is. So volume is area of the base times height. Now, in order to do this, if it's a triangular prism, we'd have to make the triangles the bases. If it's an oblique prism, we'd have to make those oblique rectangular prisms. We'd have to make the parallelograms the base, and then we can use this principle. So here's an example of find the approximate volume of the triangular prism at the right. So in order to use Cavalieri's principle and our base times height formula, we have to make the triangles our bases. So what we do is we just find the area of those triangles. So they are equilateral triangles. So the formula for an equilateral triangle is s squared root 3 over 4. So this is going to be 8 squared root 3 over 4, or 64 root 3 over 4, or 16 root 3. And then to find the volume, what we do is the volume is going to be the area of the base times the height. So it's going to be 16 root 3 times the height going back. Remember, because we actually made the sides the bases, the height of this is the 10. So this is going to be 160 root 3, and if we put that in our calculator, I get about 277 inches and volume, so it's cubed. Soapy. Okay. Volume of a cylinder works exactly the same way if we count this cross-sectional area and all the way up. The only difference is for a cylinder, the cross-sectional area is going to be a circle. So the volume of a cylinder is the product of the area of the base and the height of the cylinder. And if you want a more specific formula, it's going to be pi r squared, the area of the circular cross-section, times the height. So the next one, they want me to leave my answer in terms of pi. So the bases of the circle, and the radius is 3. So the volume is going to be the base times the height. So it's going to be pi 3 squared, and the height is 8. So this is going to be 9 times 8, or 72 pi, and check our units, centimeters cubed. Done. Just like we did composite figures, we're going to do composite space figures, so three-dimensional composite figures. A composite space figure is a three-dimensional figure that is a combination of two or more simpler figures. So use composite space figures to estimate the volume of the backpack. And just like I did before, I am going to break this down into smaller volumes. I'm going to write a very, very broad formula, and then I'll slowly work my way down. So if I take a look at the top part of this, now remember I'm not doing surface areas, so I don't have to think about lateral areas and things like that. If I take a look at the top is half of a cylinder. So the volume of the total is going to be 1/2 the volume of the cylinder plus, if you take a look at the prism that makes up the bottom, it's the whole thing plus the volume of the prism. So this is going to be 1/2 pi r squared h plus, now so I can use the same height, I'm going to make the base of the prism this front part, and that allows me to use the same h and I don't have to have subscripts. So what I'm going to do for this one is the area of the base it's going to be length times width times height. The radius I can figure out. What I have is this is 12, which means this top part up here is also going to be 12, which means this radius right here is going to be 6, so pi 6 squared. The height going back is going to be that 4. Equals plus. The length is 12. Now the width, the whole thing up to the tippy top is 17, and that radius is 6, so this height right here is actually going to be 11 because the whole thing going up is 17, and then this radius part here is 6. Okay, so I'm going to get 12 times 11 and the height times 4. Now it says estimate, so I am going to put this one in my calculator, but let me simplify it. So this is going to be 36 times 2, so I get 72 pi plus 12 times 44, 528. And if I do 75 times pi plus 528, I get about, and I'll round it to the nearest whole number, so this would be about 574 inches cubed. And that is it for today's notes. Thank you for watching. Have a great day.